Hello everybody and welcome to this XP Live webinar. My name is Nicole Highhouse and I'm the Marketing Manager here at XP Solutions in our Portland, Oregon office. Today's webinar, or this webinar actually, is the second of two identical but live webinars wherein we'll be discussing the concepts of stormwater design versus modeling and which tools to use on which projects. So if you're here for that information, you're in the right place. Today's presenter is Zach Sample, our Stormwater Products Manager. He has over 10 years civil engineering experience in site design, stormwater planning, and hydraulic analysis. Zach has performed a number of advanced water resources studies, including hydrologic and water quality system assessments, 1D, 2D hydraulic river and floodplain studies. During his time with XP Solutions, Zach has helped hundreds of clients with their models, so his voice may be familiar to some of you. Thank you for joining us today, and Zach, would you like to take it away?
Yeah, hi. Thanks, Nicole. Thanks, everyone, for joining here today. Let's just jump right in here. Again, as Nicole mentioned, my name is Zach Sample, and got a few pretty cool things to talk about here today. Before we begin, most everyone, I believe, who's joined today has probably heard of us, perhaps even heard of some of our products. If you haven't, if you're a bit new to XP Solutions as a group, so we really pride ourselves on having a very long history of providing original high-performing software solutions. And as Nicole mentioned, I was heavily involved in leading the technical team for a number of years. So really, we pride ourselves on kind of being leading in the industry for that customer service, support, and advocacy for our user base. So today, we're going to talk a bit more of kind of an educational session about design and modeling. So I myself focus a lot of my time on one of our products. It's focused on the design world, XPDRAINAGE in particular. But I want to take a step back and look at kind of the two facets of what we deal with in most cases, design or modeling. So today's agenda, we're going to talk about just simply what is design, what is modeling, kind of the hows and whys of those two different approaches. Something I like to call it effective goals to seek out when we're doing these projects, and ultimately talk about XPDRAINAGE and XPSWMM. XPDRAINAGE, the tool that I'm most heavily involved in at the current time. This is our design-focused tool. XPSWMM, many of you are probably familiar with this. This is more of our modeling design, modeling-focused tool. So back to the basics, the real dry definition of design: a plan or drawing produced to show the look and function of a building, garment, other object before it's made. Okay, that's the textbook definition of design. The key here is we're planning, designing something before it's actually made, whereas modeling, kind of a little bit different, right? It's, in this case, the kind of mathematical model is a description of a system or process to assist calculations and predictions. Okay, so we're looking at something that's perhaps already made, already built, and really maybe seeing how this larger system behaves. So a very high-level view of kind of the infrastructure life cycle. Okay, before we even talk about the specific products, this is the life cycle that we're going to, in the real world, deal with. Obviously, we're going to start with that first bud of idea. Okay, there's a need, and then that begins to precipitate kind of the rest of this process. So there's a need. We get into the feasibility, which is where both modeling and design begin to key in. Feasibility, concept, detailed design, and construction. Okay. You'll see design really kind of stops at that construction part of this life cycle, whereas modeling really continues through O&M, really tracking that system, adding in some of that monitored data perhaps back into your model to see how well it's behaving or how true it's behaving. So it's a couple high-level, maybe drier definitions. So this is maybe my personal definition of stormwater design. So it's finding the smallest sized system which allows for safe passage of stormwater. So this is a very concise statement here, but regulatory drivers are going to influence that, what the smallest size can be. Safe passage, pretty general term, but that's going to span a wide range of potential situations and rainfall scenarios. So the smallest sized system for safe passage. That's what we're designing. Stormwater modeling, a little kind of larger scale. It's an assessment or an understanding of an existing process and how it's affected by change. So you might stop in a model scenario just seeing how an existing system behaves. Okay? And then perhaps we want to propose changes to modify this. We'll see how that system as a whole is affected by that change, so we begin to add those new items in. So those are the two pure design modeling definitions. Something in between, can we do both? Yes. Yes, we can. And we'll find that in a lot of cases we might do that very commonly. So I actually have a poll that I want to have everyone jump in and try out. So you can interact with this, so go ahead and click on the screen. And I want to see who feels like they perhaps work maybe just in design, just in modeling, or perhaps a mixture of both of those worlds. So go ahead and click through there. I'll show everyone the results once we get it. I'm going to talk at length about these different items. This is kind of a fun way to see from the starting point how we feel about our projects. So we'll see, the vast majority of people would really consider their work kind of bridging both, okay, storm, design, and modeling, all right? So we'll talk certainly at that. Looks like there's a good amount of people that have, just storm design in particular. So that's great. That's really interesting to see. So let's talk about design first. So really why we would design. So the first piece is simply going to be safety mitigation. Right? So we want to prevent offsite impacts. That certainly is going to go for really kind of all engineering work. That's one of the first things we do. The pillar of engineering, is safety. Okay. The next piece, understand the costs. Right? We only have so much money to spend, for better or worse. So that's a lot of what our design is. How safe it can be, right? But then how much that's going to cost. So we kind of weigh those two together. And ultimately, maybe this is something that's overlooked from a high group, but we stop the design process kind of at the construction part of the life cycle. So we are directly making buildable plans, right? So we're figuring out what we can do and how much it's going to cost, and we hand it over to someone to build it. So how are we going to design in the stormwater sense? We're going to use really kind of a combination of volumetric, I might call static volume design tools, and also kind of dynamic hydraulic software. So really it's kind of all in one place. You want volumetric sizing and dynamic hydraulic design software kind of in one package. So things we're going to design. There's really three things on every project, it seems, at least in my experience. Proposed pipe network. Well, that's going to be one. All right, so you're going to have a pipe that's going to drain into some sort of storage facility, and that storage facility is going to have some kind of outlet. Those are really the three main things you're going to see on every project. So clearly, what kind of storage facility? Well, that's really variable. You can have a pond, underground storage. Another item, we could have water quality facilities, water quality storage. Okay, now that is pretty well kind of the fourth thing that we're doing on every project now. Certainly new development, almost everywhere in the U.S. that is a requirement to implement these kind of green facilities, bioretention, swales, filters, so on and so forth. So certainly traditional design, I'd call it. A pipe drains into a pond, there's an outlet. Really where we are now is we're doing retrofits to incorporate water quality systems, or any new design, you have to have water quality in addition to kind of your traditional drainage system. So stormwater design in general, we're looking at smaller, directly regulated problems. Now I say the word scripted in there. While the document might be 200 pages long, we're really given all the direction that we need of how to size and what is considered safe for this process. We're going to look at modeling being a little more of an open-ended question. So what we need from our design tools. So in particular, volume sizing options. So something I've talked about in a number of presentations for XPDRAINAGE being our design tool. We really want to focus on going from 0% done, or back of the napkin, I like to call it. So we're going to go from back of the napkin all the way to almost completed as quickly and thoroughly as possible. So that's really the volume sizing, having an intelligent first starting point on a project. So give it an initial smart guess, and then begin to analyze that with full hydrograph hydraulic simulation. So that's for the fine-tuning, the balancing of all the timing, the outflows, depending on your design constraints. So we really do have to have both items, I find. Start at a good place, and then the fine-tuning in the complex sites, you have to have a full hydraulic simulation. So you can get away with not doing a lot of volume sizing to start with, but really you have to have a full hydrograph system. The other piece here is the ability to robustly account for all the tricky pieces. So we're talking about the water quality facilities, infiltration items, complex outlets. So water quality facilities in particular, we'll look at this later on. They can be a bit more complex. Maybe there's multiple layers of filter material, a fine material, then kind of a coarse strain. How does water get through hydraulically and the timing through all of these filters out into the outfall structure? All that has to be accounted for, right? So it actually is quite a complex problem when we design. So meaningful output, graphs, tables, what have you. What we really care about is flow rates and volumes leaving the system. That's what we are designing around in the majority of cases. So we can't discharge, we can't impact beyond our existing site conditions. So we need to make sure our flow rates and often our flow volumes are held to what they were in the pre-existing conditions. The other is we also need to attenuate some of the pollution that's going to be generated off our site. So that's another one. So flow rates and volumes, what pollution are we removing? And very practically speaking, when we're designing, we need to know a couple of very specific items. One would be perhaps flow over capacity in the pipes. So when you're sizing pipes, the best way to do it, I guess in my experience, would be to look at the flow that's being pushed through a pipe and then look at the capacity of that pipe. And if you find that the flow that's being pushed through there is greater than the capacity, well, that means you're probably surcharging that pipe. And we don't want to do that. Okay, so we'd have to upsize the pipe until the flow through it is less than the ultimate capacity that a pipe can carry. So that's one way you could really quickly and effectively size a pipe. Similarly with ponds or stormwater controls, I want to see if my system behaves correctly, right? So if I'm attenuating enough. But one real key indicator would be how much over or under capacity are my ponds or green facilities. So seeing just a percentage of I am 15%, oversized or 15% extra volume, well, we only want, right, the smallest size that we can get away with to be safe. We don't want to waste space. So that's something we could easily scale our facilities up or down if we have that kind of information. So we can jump over to the modeling side now. So why do we model? So the first thing we're going to look at, kind of that development planning point of view. So think about, don't build in the floodplain. Okay, so that's a very real problem in a lot of cases. Portland, Oregon, we have a lot of areas where perhaps people were allowed to build in the floodplain, and now we find that's causing some real issues. So we want to model and find out where the floodplain is. Well, there's also kind of safety concerns tied into that. So there's developing in the floodplain, which would mean we kind of raise the level on someone downstream. Also, being in the floodplain would be, a safety concern. So, flood emergencies, toxic spills, okay, a lot of hazards. So those are things we want to assess and model. There's also infrastructure improvements. So think about identifying the weak zones. I might call it kind of hot spots in an area. So you might have a model of kind of a regional sized outlook for all of LA County as an example, and you might identify different zone of, hey, this is zone 1, really high priority hotspot we want to fix. Zone 2 and 3, perhaps less emergent area. So maybe you can identify zones in your city, and these are the zones that we put our infrastructure dollars at first. Okay, that's kind of a larger scale, regional sized model. So how do we go about this really is important. We need to have advanced hydrologic and 1D, 2D dynamic hydraulic software. So all of that together is how we're going to achieve these kind of studies, these kind of models. So things that we model, similar, I guess, to the design world, pipe networks, though we're talking about just a different scale, perhaps. Existing or proposed pipe networks is something I'm going to highlight here. So we might look at what is the existing, I'll talk about City of Portland. Maybe we're going to look at all of the existing sewer system for City of Portland, and then we can identify how it's working if we want to change something. Any changes we're proposing, we could see how that affects the whole system. We might look at sanitary sewer overflows, as my son would say, yuck, right? That's kind of a nasty one. We want to identify that before it happens, certainly. Flooding, right? Anytime we're overland, have overland flow, that's a big one we want to assess because that can be really, really dangerous. So inland all the way out to coastal flooding, something we want to understand and assess before we really get these events. Something that's pretty dramatic, pretty drastic, things that break. So pipe bursts, levee failures, pumped systems. We need to know what happens when these systems work as expected and don't. Okay, so those are things we're going to model and assess, and often very, very complex, or maybe also very large scale. I'm going to highlight one-dimensional, two-dimensional problems. So one-dimensional might be a pipe network. It's a one-dimensional hydraulic assessment. Sewer overflows, that's a 1D and 2D assessment. Overland, when you get overland, that's a two-dimensional assessment. So flooding is really a 2D problem. And things that are really complex, things that break, like levee failures or pipe bursts, that's a 1D, 2D kind of integrated, just like that sewer overflow thing would be. In general, we're answering questions about large, complex, multifaceted problems. That's what we do with modeling. So what we need from our modeling tools. So we need very robust dynamic hydraulic engines. So we need a coupled 1D, 2D hydraulic engine, and we also need full hydrograph, sometimes even continuous rainfall options. Continuous being 1 year of rainfall, recorded rainfall. Sometimes, it's a little more rare, but sometimes you look at 50 or 60 years of rainfall to just see how a site behaves in a lot of detail. And here we need to account for, as I said before, all the tricky bits. These are a little different now. We have groundwater influence, infiltration that occurs, complex structures like the levee structures, pumped systems. Okay. So it would be meaningful output for a model. So graphs, tables, what have you. What do we really care to see? When it comes to flooding, we really care about three things: depth, velocity, and ultimately the extent at which that flooding goes to. Those are really the three things we care about. We care about both in pipes and above ground. We care about time, the timing at which something occurs, and also the duration that something is surcharged. I want to know how long my main roadway will be underwater. Right? Emergency vehicles need to cross that. Same with a pipe system. I want to know how long a system is surcharged or the timing within it. Ultimately, the flow rates and volumes leaving a system, leaving a pipe network in particular, are key items that we look at. So that's kind of purely design, purely modeling. Well, what if we need both, right? What if something is kind of in between? So yes, we do this quite regularly, as people mentioned in the poll. They feel like they do this all the time. So can you design with modeling software? Yes. So think of, you have a citywide, very complex storm sewer system, and you find a couple hot spots, I might say. So maybe you want to upsize a couple pipes, but it's all interrelated, right? So we might use a modeling package and have a little more manual iteration to size something, but it kind of lives in that modeling space. The opposite side would be a system assessment, you call it modeling, of a multifunctional design. So I might think of this as, in design, we no longer just see if our see if our detention basin works, right? So we used to just size our detention basin. Is that big enough? Done. We don't really do that anymore. We have these green systems or distributed drainage. So we need to really design and prove a whole range of different items. We need to prove that our water quality system works, that it works with our larger protection events, and that they also together as a whole system will behave accordingly, or as expected. So basically, what's the hardest part? Use that approach. So for the one I was just speaking about, right? So where you have kind of multiple different design criteria, you're doing design. You just have to do a lot of it. So you're going to want to use a robust design package, I might say like XPDRAINAGE, because you need to do so much design. We're going to assess the system as a whole, but after a lot of design work. Okay? So that's really where that would live. So if you were looking at a very large scale model of something, and you're going to have maybe a little bit of design, well, you might use a tool that doesn't have as much of the design automation, but it has a lot of the large-scale assessment tools, because that's the hardest thing to set up. So it seems like a lot of people might live in this space where they have kind of a lot of demands for their design tools, or some design components of their larger modeling assessments. So here I guess would enter XPDRAINAGE and XPSWMM. So we have two separate software tools. It might go without saying, again though, these are two completely separate software packages. One is not a module of the other. So first, XPDRAINAGE is our design-focused tool. So you can think of this as get the right fit clearly and quickly. That's what XPDRAINAGE does. XPSWMM is that modeling-focused, very robust, understanding the impacts and assessing the possibilities of a system. So let's look at these a little further. So we have XPDRAINAGE. As I would say, XPDRAINAGE is going to allow for quick to assemble, clear to communicate, and thoroughly reviewable, sustainable stormwater plans. So I say sustainable, but we can look at both water quality green infrastructure as well as our traditional pipe channel pond designs. So we're going to look at that all in the same package. So in particular, the real strong points for XPDRAINAGE, we have this design focus, automating the design, making the design easier. How big do my pipes need to be? How big do my ponds need to be? Outlets, and you name it, the things that we need to get a really good, intelligent starting point, okay? And then also from there, run the assessment to fine-tune those. That's what we're doing here with a lot of the automated design components of the software. And I guess one step further, runoff reduction is a very specific way to design and size for green infrastructure in particular. So we actually have kind of a one-click optimizer for a whole site. So we'll look at all the inflow areas that drain to your green infrastructure, and we can size those based on runoff reduction requirements. All right, so that takes the headache out of a lot of back and forth between different tools. It's kind of all in the software. So XPSWMM is going to allow for a lot of things. Defining the existing processes, be that just hydrology, maybe it's a really large regional hydrologic assessment. We can do that. Maybe it's defining, as you kind of see down below, the full hydrologic and hydraulic system that exists. define the existing process, replicate that natural hydraulic behavior, and ultimately understand the consequences of change. So we'll see this image in the lower right, this urban flooding 1D, 2D model. We're seeing we made some kind of, on the shoulder of the site, made some detention storage. You'll see how much that reduced flooding in the urban area. That's the kind of stuff we're going to look at with XPSWM. So I'm going to try to focus on some very specific differences between the two packages. Hopefully this is clear. So XPDRAINAGE and XPSWMM. Basically, because of the way we design, we aren't going to design something that's 1,000 square miles, right? We're probably going to have a development that's anything from half an acre, just a one-lot site, up to a few hundred acres. That is the kind of item we are going to design. So that's why the software really caters to that size of development. So this could be retrofit, this could be new development, but that's really the scope at which we're operating in a design world. So XPSWMM, well, you could look at 100,000 acres. You could look at regional studies, 20,000 manhole systems. Okay, well, that's kind of the difference in scope. Modeling, we're looking at these very large scale items, just seeing how they all behave as accurately as possible. Drainage, we're designing and laying out these new pieces. Next is drainage really excels in stormwater, and in particular that water quality element, the sizing of those and assessing pollution. So stormwater and water quality is what XPDRAINAGE focuses on. XPSWMM has storm, water quality, as well as sanitary and flooding, right? So there's a lot of elements in that tool to tackle lots of different projects. So one focus of XPDRAINAGE is on that intelligent volume and water quality sizing, okay? Whereas XPSWMM is really going to be able to look at complex, I'm saying inflow, but really it's that complex site, be it hydraulic inflow, just runoff, even two-dimensional direct rainfall into a system. So that's really where XPSWMM excels, setting up this complex kind of ambient issue that we're going to try to fix. Again, drainage being a design tool, we have integrated very directly our plan view layout with what's being calculated, something that really is important for design. Well, perhaps not as important for a model, and in this case, I'd say the SWMM really excels at this dynamic 1D, 2D coupled solution. That's a strong point there for SWMM. So if you need that 1D, 2D coupled tool, well, that's SWMM. Okay. And really the last one, XPDRAINAGE has a much lower price. SWMM is higher. So XPDRAINAGE, I think I'll talk about it again, I think on the next slide, but XPDRAINAGE, for what it's worth, it's $80 a month for a year for a license. So just $80 a month. That's at least when I was practicing, that's a single draft person's hour, right? A billable time. So for kind of 1 hour a month, that's the price of the software. SWMM can range from $4,000 to $40,000, right? So it's much higher. It just does a lot more, much more robust studies. So that's, I guess, also a big difference between the two tools. So that's kind of a bullet list, maybe a little more of the, I kind of describe some of these differences. I'll use XPSWMM as kind of a known entity. Most people have heard of, seen, or use XPSWMM. So I'll talk about XPDRAINAGE in particular and kind of compare that to SWMM as we move through a couple other items. So one, XPDRAINAGE doesn't require extensive skill or product training. Not necessarily that XPSWMM does, but drainage is really intended, first and foremost, to be approachable and easy to understand. So we want someone to be able to do a kind of preliminary layout of a system just as easily and just as robustly as the detailed design phase. Okay, so the software we've made very, very consciously as easy to get into, yet still being very, very robust. So the detailed design still happens in the software, but it doesn't take a lot of training to kind of get your head around. So XPDRAINAGE, as I mentioned before, is best for site level or municipal level work. You know, we're not looking at, again, designing all of LA County's pipe system. Well, it already exists. That wouldn't be a project we'd take on, right? So we're probably going to look at, let's say, a few city blocks of, we've identified some hot spots with, let's say, XPSWM. Let's zoom down and scale and see how we could design or change some of the pipe system. That's something you could do with drainage. XPDRAINAGE is really tailored for the tricky LID and traditional facility design. So, you know, the way at which hydraulically water moves through filter layers, out under drain pipe, overtopping of weirs, that's kind of tricky. And that's something that XPDRAINAGE does very specifically and very well. Again, the pipe design, you know, the hydraulics of the pipe and pond system, it's all going to be there together. That's really where the focus of drainage is. Another item, XPDRAINAGE is going to allow for easy communication of designs, so both traditional and green stormwater systems. I'll try to look at a couple of these at the end, where this is really important, and I think where a lot of time and kind of waste is made on design projects. Right? So when we don't really see, we can't communicate to others what we're intending, we can't readily share our design, we'll see saving things out to CAD files, let's say, showing what we're proposing at any given time. Really important in the design world. So it's that design communication is such an important item when we're going to construct something. Okay, so it's really a focus, much more a focus in drainage than in XPSWM. You know, and the last point here is XPDRAINAGE is really just a fraction of the cost of XPSWM. So that's also, you know, a pretty big difference. So let's take a look. I just want to show a couple things in terms of XPDRAINAGE. Show a couple items I mentioned, and obviously any questions that you have. I think we've kind of answered through the questions field anything that's come in so far. So go ahead, and if you have something while I'm showing the software, go ahead and add that to the questions, and we'll try to address that as we move along. So this is XPDRAINAGE I'm showing. I happen to actually be showing a bioretention system. So there are a couple things here. We have the input. All of this is automated for us. So I have a surface that's loaded, and based on how I drew a shape, in this case I happen to draw a kind of kidney-shaped rain garden. Based on how I drew that, the surface was sampled, and it automatically gave me my top and bottom elevations, and it automatically, since I drew this to scale, it tells me exactly what that footprint looks like. You can see the image of, we have a ponding zone with filter layers down below, so on and so forth. So I'll just look at some results just to give us an idea of what's happening here. So in design, some of the ways we're communicating this, I've said, right, we happen to see a profile of, you can see we actually have the flow through the filter material in the ponding zone out of the system. You know, this is a pretty complex and real simulation. We're actually looking at that. We aren't simplifying these items, perhaps, you know, inappropriately, down to, you know, an effective sized bathtub, right? So we aren't taking this complex structure and just kind of ignoring the fact that there's filter material and just making it, you know, 30% smaller. We're actually assessing all the filter material and all the filtration rates through those items. So we look at some results. One thing I mentioned before was the design. So when we run a model, we'll look at this flow over design capacity here. So if we have a value over 1, means we're trying to push more water through a pipe than it's going to hold. That means it's surcharged. So anything under 1, that means it's probably healthy. We have all sorts of output, you know, just flow goes from which pipe to which pipe, the flow rates. Another one would be our stormwater controls. You can see inflow to a pond, outflow, max depth. And here's that what I was talking about, the percentage available. Flood risk means we're within the freeboard of one of these facilities, but I still have about 15% extra capacity. So maybe this is oversized, but this one, my swale, it's overtopping, right? There's no extra room. Perhaps we need to bump that size up. So ways we're communicating this clearly to ourselves. One item here I'll show. We can get into all sorts of graphs or to see the trends, let's say, of our systems. I'll turn a bunch of these off. So you can see the trends, inflow, outflow, all the results you'd ever care to see, the time series. If you're an engineer, this might not do anything directly for you, but if you're trying to communicate this to, let's say, someone that doesn't have an engineering degree, seeing a 3D view of a facility and the simulation really is going to make a difference. It's going to kind of click for them. So we're showing through profiles, through tables, through graphs, all the different ways that our design is operating, and we can compare that kind of across our site. Okay. That one kind of foundational idea I mentioned is how we're locking everything here in to plan view. So here I'll show, I happen to have this rain garden. We have a range of sizing tools. So design tools, we have these options here. We also have the sizing calculator, kind of the same thing but just for one facility. I could select runoff reduction, right? I could select storage estimate, and it will apply those design criteria to this facility and give me a volume. And now what we'll see is this volume, you see in the lower right corner, it shows me the total volume. I could change the layout of the site or the volume I want it to hold on to, and it will push that out to plan. So as an example, this radio button says, hey, give me the new top area. If instead of vertical walls, I'm going to say I need to mow this site. So I need a 1-to-4 slope. So I apply that, and we'll see our facility gets larger. So we're never going, as I used to do, never going off into the corner of the office with an Excel spreadsheet to design the pond and then coming back a week later and handing that off to someone else. Right, well, now we can see exactly how our design fits into the site. We can even see, if someone updates the CAD file. Let's load that CAD file, see if our pond will still fit. I can save this all out to CAD. So I can save DWG with all of my layouts, right, all my plan, and someone could see where I'm proposing my ponds or my distributed drainage. So they'd know, I better not flip the egress of the site. That's going to be right on top of the pond. Okay, so that's really a fundamental item. The idea that we're referencing a surface which kind of automates our first pass of elevations, tying in our calculations to the plan view. So that's the real backbone of the software, in addition to all the different sizing options. We have global runoff reduction sizing. I can hit the button and it will size up or down all the facilities on the site based on our runoff reduction input. So without diving too far into that, that's just a little brief look at some of the items I mentioned for XP drainage. Obviously, XP drainage in particular, what I focus on, there's a trial you can download available for purchase. A lot of information on our website, as you can imagine, xpsolutions.com. So you can contact AM Sales, AM as in America, AM Sales at xpsolutions.com to request information. I'll say thank you to everyone for joining. Again, my name is Zach Sample. This is XP drainage we looked at towards the end. Questions, comments, be happy to hear them. So thank you for joining. Have a good day.